J is a general-purpose, high-performance, array-oriented programming language. It is also a notation for expressing computational concepts clearly and concisely. We're going to show you in 10 minutes how to write a full-fledged desktop application in J based on the Qt User Interface Framework. First, we see an example of an interactive J session window, the version that runs under the Qt Graphics Framework. The lines beginning with capital NB dot are comments. We start defining the GUI in what we call a noun, which is a variable named firstGUI. This noun lists windowing commands to define a parent control named first, labeled with the text my first window. This parent contains a child control, a button named but1, labeled with the text my first button. Next we define a J verb, a program named firstStart to start up our GUI object. This verb runs a series of WD commands to perform different windowing operations based on its arguments. These arguments are character strings. The first WD command uses our previously defined first GUI noun as its argument, defining the form we mentioned before. The second use of WD invokes the command pshow to display the form. The third WD command places the form 600 pixels over and 300 down with a size 200 across and 200 down. Finally, we define the event handler to close the window as the J verb firstClose. In the body of this definition, we invoke the WD command pclose to close the parent form. Once we finish defining these, we run what we've written by invoking the firstStart verb with a dummy argument of quote, as all J verbs need at least one argument. This gives us a window we can close, but the button does nothing when pressed. To make the button do something, we need to define an event handler for it. We link this event handling verb to the button to which it applies by its name. Since this is the button labeled but1, the name ends with _but1_button. This verb invokes the WD command mbinfo. MB brings up a message box of the type that simply displays an informational message. The message displayed is the text my first event handler. Running firstStart again allows us to press the button to see the information message box it produces. Now that we've explained the basic window building primitives, we'll build a more complex application for looking at Swiss weather data over about 140 years. We have this data in some CSV files. Here, we use the standard fread verb to read one of these files. We assign the contents of this file to a noun called data, then display it by entering the name of this noun. Each line of this data starts with a letter designation, followed by a year, month, date, then some numbers for that date. We also want to use some weather station data in another CSV. We'll assign the contents of this file to the variable, the J noun, stat. Typing stat's name displays its contents. We see many lines of data, the meaning of which we'll touch on later. Now, instead of dumping the contents of these files to the screen, we'll read them into J tables, taking advantage of the CSD formatting. First, we load some standard utilities from tables/DSV. Next, we use one of these, readDSV, delimiter separated variables, to read the CSV file as a J table. Actually, this file has fields on a line delimited by semicolon, not comma, so we indicate this in the left argument of readDSV. This gives us the array data, which we then display. Notice how these fields are now boxed items rather than the lines of text we saw when we simply read the file. We do the same thing with the other file into the variable stat. A display shows us that this too now consists of boxed items rather than simple text strings. Looking at only a single record, we can examine the format of its items in more detail. We see that the first item is a short code indicating a city or region as shown in the other variable above. The second item is a year month as a string. This will be more useful as two separate numeric fields, so let's see how we would convert this string into these two numbers. We'll also convert the strings in the last two columns into numbers. We start with the year month column, turning the string into a number using activate or double quote dot on each item in that column. We unbox the numbers using unbox, the greater than symbol used with only a right argument, and divide all these integers by 100 so the month is the fractional portion of the number. Next, we extract the years as a box series of integers by rounding down the year-mon numbers using the floor or less than dot verb. We extract the months by subtracting the rounded year from the number, leaving only the fractional part, and multiply this by 100 to get a whole number. Now we build a table from the data with numeric columns for year, month, and the two other numbers. We also append the three-letter code as the initial column. Let's define some utility verbs to extract these columns of data in a useful format. You'll see that all three of these look very similar to each other, varying only in the last part of their names and in the number of the column each extracts from our data table. We test these new verbs to see if they look like they're returning the parts of the data table we expect. The data getStation verb selects only those rows beginning with the specified three-letter station code. We use the result of this as the left argument to data getYear to select only the 2012 records from among the station records we've selected. We then use the results so far to select only the month 5 records for the given station in the given year. This gives us only a single record. Since these seem to work as expected, let's move on to the weather station data we have in our statnow that we read file earlier. First, we'll filter the station data to include only the stations referenced in our weather data. We want only the stations labeled BAS, SMA, etc., and the clear text plus the data only for these stations. This updates the noun stat to contain only the list of 13 weather stations as seen here. Now we'll create another utility verb to extract a weather station's clear text name given its three-letter key. We check if this verb works as expected by calling it with the argument BAS to see that it returns the name Basil Binningen. Using this verb with the argument SMA returns the clear text Zurich Flintern. Once we've done this, we can visualize selected data over the time for a given station, SMA in this case, for a specific time period, the year 2012 in this case. Here we see a plot of temperature data for this station and year. Now that we've completed all the basic parts of our desktop application, we want to bring them all together into a single script file. We would like to save all the useful verbs we've created so far in a single file so we can examine, modify, and run them easily. Here, we see an example script in the window on the right. This script, entered previously, contains the elements we've covered so far in our application. We scroll to the bottom of the script to the definition of the GUI we'll show. We run the script by selecting Run/Load Script from the taskbar. This brings up a 3-column selection dialog above a plot reflecting the current state of the selections. We see how changing the selections immediately changes the plot to reflect this. Selecting the star at the top of year or the month choice selects all the values in that column. So here we see the plots for August of all years in the Zurich Flintern region. Selecting the last year and all the months shows us the data for all months of this year. Thanks for watching. You can go to jsoftware.com to find out more about J, and there are some other links here for you to take a look at as well.